Invisible atmospheric tapes quietly dictate our daily lives and shape future global weather patterns. These unseen records, stretching back centuries, hold profound secrets about Earth's dynamic and unpredictable climate. Without understanding their intricate patterns, we would remain utterly blind to nature's most powerful forces. They are the silent architects of every storm, every sunny day, and every breath of air we take. Atmospheric science relies fundamentally on meticulously capturing and preserving countless environmental data points. This continuous process of taping, or recording atmospheric conditions, began long before digital computers existed. Why should we care about old weather logs or sensor data streams? Because they unlock critical climate insights. Imagine trying to predict a complex system without knowing its past behavior or current operational state. From ancient mariners tracking winds to modern satellites observing global temperature shifts, data collection is paramount. These recorded observations form an irreplaceable tape, documenting Earth's atmospheric evolution over vast timescales. Understanding these historical records allows scientists to discern subtle trends hidden within the noise of daily weather. Without this robust data tape, our grasp on climate change and extreme weather events would be severely limited. This fundamental data, taping, provides the very foundation for all contemporary weather forecasting and climate modeling. It is the bedrock enabling us to anticipate droughts, floods, and even the paths of powerful hurricanes. Essentially, this continuous data stream is our planet's meteorological diary, chronicling its every atmospheric mood. This meticulous historical record becomes an indispensable guide for navigating future environmental challenges. Early atmospheric scientists devised ingenious methods to automatically tape conditions using mechanical instruments. Barographs, for example, used rotating drums wrapped with paper to physically trace atmospheric pressure changes. Thermographs similarly recorded temperature fluctuations, with pens marking waxed paper over daily or weekly cycles. These fragile paper tapes captured invaluable local weather histories, sometimes spanning decades from remote stations. Imagine a delicate clockwork mechanism silently charting the unseen forces of wind, heat, and moisture, day after day. But how did these isolated measurements combine to form a comprehensive global atmospheric picture? Eventually, networks of observatories started systematically collecting and sharing these localized, taped data sets. This allowed for broader understanding, but manually compiling such vast amounts of analog data was an immense task. The advent of electronic sensors revolutionized this taping process, making data collection far more precise and efficient. Automated weather stations now continuously measure temperature, humidity, wind speed, and precipitation every few minutes. These digital records are immediately transmitted, forming a real-time tape of current atmospheric conditions globally. Wait until you discover what happens high above the Earth's surface for even more data. Weather balloons carry instrument packages, known as radiosondes, high into the atmosphere, taping vertical profiles. They transmit crucial data on temperature, humidity, and wind direction back to ground stations during their ascent. Then there are weather radars, which send out radio waves to tape the location and intensity of precipitation. Orbiting an Earth yet, tools cannot capture the full atmospheric global conditions from an atmospheric global story perspective alone. Orbiting an Earth, yet continuously taped tools cannot capture the full atmosphere and even analyze atmospheric chemistry. They monitor cloud formations, track storm systems, measure sea surface temperatures, and even analyze atmospheric chemistry. These orbital observers essentially provide an unbroken, comprehensive tape of Earth's entire atmospheric envelope. Each instrument, whether old or new, contributes to a colossal, multi-layered atmospheric data tape for analysis. Modern supercomputers ingest these enormous volumes of taped data, creating incredibly detailed atmospheric models. These models are like virtual Earths, simulating how weather systems evolve based on the collected information. Scientists then use complex algorithms to analyze the tape of historical data alongside current observations. This allows them to identify subtle patterns that precede major weather events, improving forecast accuracy significantly. Imagine a vast, ever-growing puzzle where each data point is a piece, slowly revealing a bigger picture. But what profound secrets might these colossal data tapes still reveal about our climate. Archival efforts diligently preserve old paper charts and modern digital files, ensuring no piece of the tape is lost. This historical preservation is crucial for studying long-term climate variability and detecting subtle changes over centuries. Without this continuous dedication to taping and storing information, our understanding would remain perpetually shallow. The sheer volume of this taped data truly represents humanity's ongoing dialogue with the atmosphere. Every single measurement contributes to an intricate, evolving narrative of Earth's dynamic weather story. This combined tape of atmospheric data underpins virtually every aspect of our meteorological knowledge base. The meticulous taping of atmospheric data directly translates into more accurate and timely weather forecasts. This improved accuracy saves countless lives by providing early warnings for severe weather like hurricanes and tornadoes. Farmers utilize these forecasts to plan planting and harvesting schedules, protecting their valuable crops from damage. Aviation and shipping industries rely heavily on precise atmospheric tapes to ensure safe and efficient travel routes.
Energy companies optimize power generation and distribution by anticipating demand fluctuations caused by changing temperatures.
Power urban generation and distribution by planners use anticipating demand climate data fluctuations derived from these tapes to design resilient infrastructure against future challenges. Moreover, this comprehensive data tape provides irrefutable evidence for the reality of long-term climate change. By comparing current readings to historical tapes, scientists clearly observe rising global temperatures and changing precipitation patterns. This historical context from diligently taped data helps us understand the unprecedented speed of recent environmental shifts. It informs critical policy decisions, urging global action to mitigate the impacts of a warming planet. The tape reveals patterns of increasing extreme weather events, demonstrating urgent needs for adaptation strategies. Understanding the atmospheric tape helps us prepare for droughts, manage water resources, and protect vulnerable ecosystems. Essentially, every decision affecting our interaction with nature flows from interpreting these vast atmospheric data tapes. It grants humanity a profound, almost predictive, insight into Earth's complex and powerful atmospheric engine. This ongoing record helps us responsibly steward our planet and safeguard its delicate environmental balance. Without this continuous documentation, navigating our changing world would be an impossible, perilous endeavor. The continuous taping of atmospheric data, from ancient charts to modern satellites, is truly indispensable. It's the invisible thread weaving together past, present, and future, enabling our understanding of Earth's climate. This vital work provides the essential knowledge we need to protect ourselves and our planet effectively. If you found this journey into atmospheric data fascinating, hit that like button and share your thoughts below. Subscribe for more mind-blowing insights into the hidden forces shaping our world every single day. Join us next time as we unravel another captivating mystery of science and discovery.